Hi guys, this is example number 7 in the challenge problem section. This is going to be the last example that I'm going to show you here in this section. But guys, if you have any other questions or any other challenge problems that you are working with or you're struggling, feel free to send it to me and we can work over those things together, okay? But let us look at this challenge problem. There's so much going on here. The square root of a cosine function, and then we want to evaluate the derivative of this function at a particular value, which is radical pi over 2. So in order to actually start working on this, guys, the first thing that I'm going to do is I'm going to kind of rewrite this equation. So instead of writing it as radical, so I'm going to change that as to the power 1/2. And the main reason for that is so that I can easily kind of see that this looks more like an x to the power n type of a thing, right? So I can first of all start thinking in terms of using the power rule, and then we have to multiply, because it's not just an x, there's more going on inside the parentheses. We have to obviously multiply by the derivative of the inner. Basically, we're then using the chain rule, okay? So let us start with that, defining the derivative f prime of x. First of all, I have to bring that 1/2 up front, and then whatever is inside the parentheses, I got to just rewrite this cosine square x square. And guys, I got to raise this thing to the power n minus 1. 1/2 minus 1 is just negative 1/2. Then I multiply by d over dx of this inner piece, 1 plus cosine square x square. And that's it. That's the first step here. Once I do that, guys, moving on, let us see how far we can simplify this. This we got to leave it like that, or you know what, I can already bring it downstairs like this, so I can put it in. This is 1 times 1 plus cosine square x square, right? When I bring this to the downstairs, it will be positive 1/2, which is just the radical. So putting it back there, and then I want to make sure I use enough parentheses. So yeah, this is all good. Then times, guys, let us find the derivative of this. Derivative of 1, derivative of any constant is 0. No need to worry about that. What is the derivative of this? So let us try to find the derivative of this function. Guys, this is like cosine x square, and I like to rewrite this as the whole square, because this square means it is the whole thing is raised to the power 2. And now when you see something like this, when the cosine function is squared or raised to the power something more than or greater than 1, guys, we cannot just directly start by writing the derivative of the cosine function. We have to still consider this whole thing as a big x to the power n type of a thing, right? So the derivative will look like 2 to the power cosine of x square raised to the power 2 minus 1, which is just 1, so I don't have to write it. But then I have to multiply this by the derivative of the inner, which is d over dx of the cosine of x squared. Guys, you can do all that work right here, but I'm here, in this case, I'm just doing it on the side. It's up to you. You can do it on the side, or you can do the whole work right here with the problem. But moving on, guys, here it's going to be 2 cosine x squared, and then multiplying by the derivative of this. Now the power of cosine is just 1, so we can use the basic formula for what is the derivative of a cosine function. The derivative of cosine is negative sine, so I'm going to use negative sine x squared. But again, I cannot leave it like this. I still have to multiply by the derivative of the x squared. So there's so much going on here. There's a lot of composition. So we have to keep on multiplying by the derivative of the inners, okay? Guys, I think there's one more step, and finally we'll have our final derivative of this whole thing. So it's 2. Guys, what I'm going to do here is I'm already going to take that negative with the 2. That's what we usually do, negative 2. Then it's cosine x squared, and then I have sine x squared. And then finally, derivative of x squared is just 2x. So it's times 2x. So when I simplify this, 2 times 2 is 4. So it's going to be negative 4x cosine x squared and sine x squared. So I have finally the derivative of this function. We had to do it in few steps, but finally we have it. Let me bring it back here. So it's negative 4x cosine x squared and then sine x squared. Okay, that is the derivative of this whole thing, guys. Now we have the derivative for this function. All we have to do is now maybe simplify this and then substitute the value for x, which is radical pi over 2. Guys, let us go back and simplify this first. It's not too difficult to simplify. Negative 4 divided by 2 is just negative 2. So it is negative 2, and I'll bring the x up front, and then downstairs I have 1 plus cosine square x square times, I'm just rearranging things here, times, then I have what? Cosine x square times sine x square. That is my expression for the derivative of this function with respect to x. Now I have to go back and I have to replace or substitute x with radical pi over 2. So guys, I need to get rid of this here and find me some room to evaluate this function, this derivative at radical pi over 2. So let's go back here. From here, I'm going back right here. So f prime of radical pi over 2. Let's see what that equals to. Wherever I see x on the right hand side, I'm going to replace that with radical pi over 2. So it's negative 2, and then I have radical pi over 2 times radical pi over 2. Then this whole thing has to be divided by square root of 1 plus cosine square. And x square, guys, x square means I have to square this whole quantity. When I square this quantity, what's going to happen? Radical pi square is going to be pi, and 2 square is going to be 4. Right, guys? Because it says x square, so I have to square the numerator as well as the denominator. Squaring the numerator simply means getting rid of the, we'll get rid of the square root, and we're left with pi, and downstairs 2 squared is positive 4. That takes care of this piece. Then I have to multiply this by cosine of x squared. Again, squaring the x. Squaring the x will give me same thing, pi over 4. And then again, I have the sine of x squared, which is still sine of pi over 4. Now from here, guys, we have to either go back to the unit circle or a calculator, or if you already remember what is the cosine of pi over 4 and sine of pi over 4. I think one should try to use the unit circle, because again, this was also a multiple choice problem. So in the 4 options, none of the options had any decimals. So it was, everything was in radicals. So guys, if we want to keep everything in radicals, one has to either know how to convert, like if you're using a calculator, how to convert a decimal to a radical, a fraction into a decimal and all that, or one can just use the unit circle if we don't remember what are the values of these cosine and sine functions. So moving forward, guys, this is going to be radical pi over 2 equals to, here 2 and 2 will cross out. I'm only left with negative radical pi. And guys, downstairs, let us see what I'm left with. 1 plus cosine squared pi over 4. So I think I'm going to need more space. So I will also get rid of this. And since we already have it here, we already substituted the value. I don't really need it now. So guys, cosine of pi over 4 is radical 2 over 2. So I'm going to write radical 2 over 2, but we have to square that as well because it's the cosine square. Then cosine pi over 2 is radical 2 over 2. Sine pi over 2 is also radical over 2 because cosine and sine are equal at when the angle is pi over 4. I don't know why I'm saying pi over 2. It's pi over 4 for both cases. The values are radical 2 over 2 for both cosine and sine. Let us see if we can simplify things, and one cannot leave it like this. One has to simplify. Radical 2 times radical 2 is what? It's just simply 2. So then one of the 2's will cross out. I'm only left with 2 in the denominator. And that's how it's going to look like. Radical pi over 2 is negative radical pi. And I'm also going to try to simplify this guy. Guys, inside the radical, I'm going to be left with 1 plus radical 2 square is going to be just 2. And 2 square downstairs is going to be 4. Let me write it here because then this would still be simplified to 1/2, but we'll do it in steps. Guys, here 2's cross out. I'm only left with 1/2. Simplifying further, 1 times this is just negative radical pi. Downstairs, let us try to simplify, guys. Inside the parentheses, inside the radical, sorry, this is going to be 1/2. So it is 1 plus 1/2 inside the radical, and then there's a times 2 outside. Now, let us look at this again. Radical. Well, to simplify this, we have to just combine 1 plus 1/2, which is going to be 3/2. So taking it up right here, it's going to be negative square root of pi over square root of 3 over 2. Right? 1 plus 1/2 is 3/2, and then multiplied by 2. Guys, I still have to simplify this because we don't like radicals in the denominator. Or let us see how we can still simplify this. Now this is going to look like negative radical pi over radical 3 times 2. And then there is this radical 2 here, which I'm going to take upstairs, because I'm dividing by that ratio. So when I change that to multiplication, this radical 2 goes upstairs. Now can we simplify further? Yeah, we can still simplify. There's few different ways of simplifying, guys. My goal is to get rid of the radical in the denominator. I mean, at this step we have the answer, even we have the answer right here, but we don't like to have radicals in the denominator. So to get rid of the radical in the denominator, one of the things I can do is I can multiply downstairs and upstairs by by radical 3, so that I can get rid of that radical. So it's going to be negative radical pi. We can multiply these. This will be radical 6 divided by radical 3 times radical 3 is 3. It's 3 times 2. And that will be negative radical pi times radical 6 over 6. And you can leave it like that. Or if you like, you can combine these like as negative 6 pi over negative radical 6 pi over 6. So guys, this answer, I mean, at this level you can leave it like this, or you can change it to this. In the multiple choice thing where I actually saw this challenge problem, the final answer was like that, so I kind of simplified this further. But guys, you can leave it like here. But we know that we don't like to have radicals in the denominator, so we have to rationalize like we did in this step to get rid of that radical in the denominator. Other than that, guys, the steps, I mean, I tried to write all the steps here. So this is a challenge problem, but it requires a lot of steps. Please look at the steps carefully. Let me know if you need any extra help with this problem or any other challenge problem in the derivative section. I will see you next time with new concepts.